Love you like I do. Why do? Don't know why I love you. Don't know why I care. I just want your love to share. I wonder why I love you like I.
Alright, our first discussion is going to be about Isaac Newton, well, Sir Isaac Newton, who was, to many people, considered the father of physics. He wrote many works that, if not were written, we wouldn't have a lot of the things that we have today, television, light bulb, things of that nature. The thing about Newton was that since he was a scientist, he had to have patrons to support his work. And that's where Halley, the man who named Halley's Comet, came into play. He was a very wealthy entrepreneur and a very good businessman who saw a lot of potential in Newton and decided to publish a lot of Newton's work and pretty much put Newton on the map. Now, one of the laws of physics and what really started the actual science of physics was when Newton observed an apple falling from a tree, and he started wondering and looking up at the stars, were the planets also falling towards the Earth too? Were they falling at all? If the apple fell, if things fall on Earth, I wonder if the moon is falling. And so he decided to start creating a mathematics that he could apply to basically figure this out, and then he ended up creating what we know as calculus today, a very, very complex math that some seniors in high school dabble in, but mostly around your freshman year, even your sophomore year, you cover more in depth into calculus. And with that, he could calculate as easy as an apple falling from a tree, figure out using calculus if the moon was falling at what rate. He could even calculate things falling in orbit, how long it would take those things falling, or in orbit, how long it would take them to come back around. And one of the very first things that he started observing in space was Halley's Comet, and was able to a precise number and date, predict when Halley's Comet would be orbiting visibly around the Earth. So, to appreciate the complexity of calculus and the complexity of the physics that was used at that time, when people didn't even know what anything in the universe was, that a man from a very primitive time, there was no really any other word I could use but primitive, was able to figure this out and create one of the most complex mathematics that we have today in university, not only just in high school. And that ends my discussion on Isaac Newton. The next thing is we're going to be talking about, let's cover a couple of the laws of physics. Hi. The first law of motion from Sir Isaac Newton we're going to discuss will be Law 1. An object in motion tends to stay in motion unless acted upon by an outside force or an unbalanced force. This law, also known as the law of inertia, is basically, to put it into an example, would be the path of a bullet once fired from a gun. Now, that bullet is flying through the air. Now, the friction of air and the force of gravity will eventually send that bullet toppling towards the ground. Now, without any friction like you would feel the heat from your hands doing this, without friction, the object in motion will stay in motion. Think about being in space. there's no air in space. There's no gravity in space. So an object that's going at 100 miles an hour will continuously travel at that same rate into infinity unless acted upon by an outside force, say the gravity of a planet, or it colliding with an object in space would either slow it down or project that object at a faster rate. The thing about the first law is that there was another philosopher in history who almost had the same law. He had once said that an object in motion will stay in motion until it gets tired. Now, this law was contradicted by Newton, and Newton had a better understanding of this and ended up creating this first law, the law of inertia. The next we shall talk about is the second law. Mass is equal to the force divided by the acceleration. Alright, acceleration is equal to force divided by the mass. This law from the second law of Isaac's laws of motion is fairly simple to grasp, because if you think about it, it's basically saying that the more mass an object has, the harder it is to gain speed when acting upon an outside force. Think of it like this: a person on a bicycle, a heavy set person, a larger person, when a person pushes that person, they'll go whatever distance they'll go. Now you'll take that same person pushing a smaller person, and that smaller person will travel further because that smaller person has less mass. Therefore, they can gain greater velocity or acceleration or speed, which you would like to use in that equation. It also has to do with force. The greater the force on an object, the more acceleration it'll have. Think about a tiny 7-year-old girl pushing a man that weighs 150 pounds on a bicycle. And then imagine a 250-pound muscle-bound Hulk pushing that same 150-pound man on the bicycle. The big muscle-bound guy will deliver more force to the bicycle than that little girl. Therefore, the guy on the bike will go faster. That's basically all the second law is stating. So in a way, even though there's a lot more to the law, it's actually an easier concept to grasp than even the first. And I'll be going over the third law right now. Alright guys, let's talk about Newton's third and final law of motion. Now, this law is pretty hard to grasp just jumping right into it, so I'm going to try my best to explain it the best way I can and how I was taught about it, and with an understanding that I'm just learning this stuff myself and it's pretty new to me. And even though I've pretty much read all I could on the subject at an introductory level, hopefully I can get the message across to people who are curious about this third law. Now, if you observe a walking individual or even yourself and you're looking at your feet, you understand that walking is a series of controlled falls. As you step forward, your body is falling and your feet catch your body and you continue to walk. You're actually falling. Now, the reason why you fall is due to gravity. Gravity is pulling your body downward and your feet are catching you. And which means that your body is pushing towards the ground. Now, gravity is pushing upward. The ground is pushing upward. Without that force, you would not be able to move. It's really a concept of maybe like a fish. A fish uses its fins to push through water. Now, without that water, catching the fins, that opposite reaction, the fish would not be able to propel itself forward. So, in a sense, in every movement of any object, there has to be an opposite force pushing against the object's momentum for it to actually stay in motion. And